Welcome to our explainer on a really core concept in C#, inheritance. We're going to see how this one single idea lets you write way cleaner, more efficient code by, well, writing less of it. So let's just dive right in. So let's start with a problem that I guarantee every single developer has run into. You know the drill. You find yourself just copying and pasting methods or properties all over your application. Before you know it, your code is bloated, it's inconsistent, and it's a total headache to maintain. Sound familiar? I thought so. Well, lucky for us, there's a really elegant solution to this exact problem. It's a powerful principle that's just baked right into C#, and it's called inheritance. At its heart, it's really all about creating relationships between your classes, which lets you share code and build a much more logical structure. The easiest way to think about it is like a family tree. You've got what's called a base class. That's kind of like the parent. And then you have a derived class. That's the child. The child class automatically, just by its nature, inherits all the public traits and behaviors from its parent. It creates this really nice, clear hierarchy. Okay, so we know what it is, but why is this such a big deal for developers? Why should you care? Let's really dig into how this one concept can totally change the way you write code, for the better. Look, inheritance is not just some fancy academic trick. It solves real-world design problems. For starters, it drastically cuts down on all that duplicated code we were just talking about. And it kind of forces you to create a logical structure. But the best part? When you have to fix a bug or add a new feature, you often only have to change it in one place. That makes your whole application so much easier to scale and maintain down the road. All right, let's get into the nitty-gritty. The mechanics of it. You might be thinking that something this powerful has to be complicated to set up, right? Well, you're about to see just how incredibly straightforward it is in C#. Believe it or not, all the magic happens with just a single character, the colon. Seriously, when you put a colon after a class name and then follow it with another class name, you're basically telling the C# compiler, hey, this new class is a more specific version of that other one. And just like that, you've established what we call an is-a relationship. Okay, let's walk through a classic example. First up, we'll define a very general base class, and we'll call it animal. We're going to give it a basic behavior that pretty much all animals share, an eat method. Just think of this as our general animal blueprint for now. Okay, now we'll create a more specific class. Let's call it dog. See that colon right after the name? That's it. That's the magic syntax we were talking about. It tells the program that a dog is an animal. And of course, we can also give our dog class its own unique behaviors, like a bark method. And right here, this just brilliantly shows the power of reusability. I mean, think about it. Without writing a single extra line of code for eating, our dog object just knows how to eat. It inherited that ability directly from the animal class. We literally got that functionality for free. Now, to bring this into the real world, imagine a base button class in a UI library. Every special button, like an image button or a submit button, could inherit its basic click behavior from that one place. But wait, inheritance isn't just about blindly reusing code. What if your child class needs to perform a shared behavior, but it needs to do it in its own special way? Well, let's look at a more advanced feature that gives you some incredible flexibility here. This whole concept is called method overriding. It basically allows a child class to look at a method from its parent and say, you know what, thanks for the suggestion, but I'm going to do this a little differently. And in C#, you pull this off with two simple keywords, virtual in the parent class and override in the child class. So let's imagine a base class called vehicle. It has a start method. But we all know that different vehicles start in totally different ways, right? So by marking that method as virtual, we're basically putting up a sign that says, hey, any class that inherits from me is welcome to provide its own version of this method if it wants. Okay, so now when we create our car class, which of course inherits from vehicle, we use the override keyword. This tells C# loud and clear that we are intentionally providing a new, specific implementation for that start method, maybe one that talks about turning a key in the ignition. And this is really where you get the best of both worlds. You get to reuse the general structure from the vehicle class, but you also get to tailor the specific actions for the car class. A great example is in a video game. You might have a base enemy class with a virtual attack method. A goblin enemy could override it to swing a club, while a dragon enemy overrides it to breathe fire. That flexibility is exactly what makes object-oriented design so incredibly powerful. Now, before we wrap things up, it's really important to remember something. While inheritance is a fantastic tool, it's not always the right tool for the job. So let's just quickly touch on one other key design principle for creating relationships between your classes. So everything we've been looking at so far is what's called an is-a relationship. A car is a vehicle. Simple enough. But sometimes what you really need to model is a has-a relationship. For instance, a car has a radio. For that, we use a totally different pattern called composition. See, a car isn't a type of radio, it just contains one. And this is a super crucial distinction to make because inheritance creates a really tight bond, while composition gives you a lot more flexibility to swap components in and out. Honestly, choosing between these two, inheritance and composition, is a fundamental part of great software design. Knowing when to use one versus the other is what will really elevate your skills as a developer. So that's a great question to take with you and really think about as you continue on your coding journey. Hey, if you found this explainer helpful for getting your head around C# inheritance, do us a favor and hit that like button, share it, and of course, subscribe to the Global Code Factory YouTube channel for more insights just like this one.
You can also find us on all the usual social media platforms and over on our website for even more great content. Thanks so much for watching and happy coding!